Alright guys, in this video we're going to review for your test. This test is going to go over, it's going to test you on chapter 6 and also chapter 7, section 1 and 2. So let's begin. Let's start with this one here, which is equivalent to 8 to the negative 2/3 power. So when we have a negative exponent, we know that one of the laws of exponent says a to the negative n. You flip that into a fraction, and you make the exponent positive. So we're going to do that first step here. We're going to apply this logic into that. So our exponent, we're going to put it onto a fraction, the bottom of the fraction. We're basically going to flip it. 8 is basically 8 over 1. So when we have a negative exponent, all we're really doing, we're putting the denominator in the numerator position and the numerator in the denominator position. So we have a base of 8. Our exponent now is positive, is 2/3. Now we're still not done. We still have to do something with this 2/3 exponent. Okay? Let's first try to put this into radical notation. Our denominator is 3. We know that when we switch from rational exponent to radical notation, our denominator is the index. So this is 3. So this is the cubed root of 8. And our numerator is what we're raising the number inside of the radicand, or the radical, 2. This becomes 1. What is the cubed root of 8? Now we're looking for the cubed root of 8. Break this down. This is 2 times 4. 4 is 2 times 2. In order to take anything out of the radical, we need 3 of them because we're looking for the cube root. We have 1, 2, 3 2's, so we're going to take that outside. 2. There's nothing left inside of the radical, so now we're left with 2 squared because we still have this 2 that we didn't deal with. And that becomes 1/4. So the answer to 8 to the negative 2/3, 1/4. I'm going to erase a little bit of this work so we can work on the next problem. If you want to see that again, just rewind. Let's work on number 2, which is the cubed root of 375 written in simplest form. On the test, you have to work this out, but select for multiple choice. I don't put the multiple choice selections here because I want us to work them out on our own. And then if we know how to work them out on our own, it'll be really simple to do that and then just match it to the answer given or one of the answer selections. So let's break this down. How can we break down 375? Well, we can break it down 3 times 125. Now, in order to be able to take anything out of this radical, we need to have 3 of them. We don't have 3 3's or 3 125's, so we're not done yet. Let's break down 125. That's 5 times 25. And that 25 is 5 times 5. So now we do have 3 numbers. We have 1, 2, 3 5's. So everything that we have triplets of, because we're looking for 3 of them, because we have the cube root, we put that outside of the radical. This is still the cube root. And what are we left with inside? A 3. We don't have 3 of these, so they have to be put in there. So breaking down the cube root of 375, the simplest form is 5 cubed root of 3. Okay, let's go into this one. Simplify. 27. Oops, that says 25. Excuse me, guys. 27 to the 5/3. Let's put this into radical notation. What is the index that we're supposed to have? Remember that the index is the denominator in our fractional exponent. That's 3. And the numerator just becomes the exponent inside of the radical. So now, what is the cube root of 27? What times itself 3 times is going to give you 27? Let's break down that 27. So we have 1, 2, 3 threes. We can pull that out. So the cube root of 27 is 3. Are we done yet? No, we're not. We still have this 5 to deal with. So now we want 3 to the 5th power. 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. So this is 9 times 9 times 3. That's 81 times 3. And what's 81 times 3? 3, and that would be 4 and 4. So this is 243. And that's our answer. All right? Let's work on this one. Number 4. Simplify the expression, all variables represent positive real numbers. So how can we simplify 36x to the 10 raised to the 3/2 power? Now, usually, we always have to check PEMDAS. First, we see is there anything inside of the parentheses that we need to do? There's not. There's no simplification we can do inside of the parentheses. 36 is already simplified. X to the 10th, there's nothing we can really do there. There's no addition, multiplication. We're done. Now we have a quantity, this inside of here, raised to this exponent. So what do we do here is we distribute this exponent to all the terms inside of that quantity, inside of that parentheses. We're going to distribute it to 36, and we're going to distribute it to x to the 10th. So this is then going to become 36 to the 3/2 multiplied by x to the 10 3/2. That takes into consideration a couple of different properties of exponents that we worked on in chapter 6. When we have a number with an exponent raised to another exponent, we multiply those exponents. And that's what we're doing here. We're multiplying these exponents. Now, what a lot of you have done in the past that is incorrect is you just distribute this 3/2 to the x, but not to the 32. And you still need to distribute that to the 32. That property is this. When we have two numbers being multiplied together, raised to an exponent, you have to distribute that exponent to both of the numbers being multiplied. If you don't remember this, review chapter 6. I don't remember exactly what section, but that was in our chapter 6 discussions. So let's rewrite this. This becomes the square root 36 cubed multiplied by x. Now we have to multiply straight across. 10 over 1 times 3/2. We get 30 over 2, which is just 15. What is the square root of 36? 6 cubed. 6 times 6 is 36 times 6. That is 36 and 6. That gives you 6 and 3. 3 times 6 is 18 plus 1 plus 21. 216. And we still have to bring this down. X to the 15. So we're asked to simplify. All done. That is our answers. Let's move on to the next one. Next couple of problems. We only have these to go. Simplify the cubed root of negative 216x to the 6. We're doing this one. Let's call this number 5. Okay, so how can we break down 216? Okay, now breaking down 216, we know that's 6 times 36. We just did that in the previous example. And how do we break down 36? 6 times 6. Okay, so now we have 1, 2, 3 of them. We can take them out. So we're left with 6 cubed root of negative 1 times x to the 6. Notice I left negative 1 because this was negative 216. So since we didn't take out any negatives yet, we still have to leave the negative in. Can we break down negative 1? That's negative 1 times 1. How can we break down negative 1? How do we break down 1? Negative 1 times negative 1. There's 1, 2, 3 of those. So we're left with negative 1 multiplied by 6 and the cubed root of x to the 6th. Okay? Let's bring this down here. So that becomes negative 6 cubed root of x to the 6th. How do we break down x to the 6th? That's 1, 2, 3, 4, 5, 6 x's. In order to be able to take anything out, we need 3 of them. We have 3 here. Take that out. And we also have 3 here. We can take that out. That leaves us with negative 6. And anytime you take out anything from the radical, you have to multiply it by what's outside of the radical. Times x, because we took them out of here. Times x, because we took the other x out of here. We're left with negative 6. X times x is x squared. Our answer is negative 6x squared. All right. Let's work on graphing this function. Actually, I'm going to skip that and leave it for another video because we're running really low on time. So, matter of fact, this is the end of this video. I'm going to record another one. And if you want to see number 6, 7, and 8, and I'll probably have a couple more, go to the next video. I'll post it up on Edmodo shortly.